All right, we're going to wrap up section 2.1 today. If you've noticed, a lot of the chapters in our book only have 2 to 3, maybe 4 sections. However, each of them are pretty lengthy, and that's the case with this one. There's a lot going on in section 2.1. We started by talking about frequency tables, where we did like the tally and the frequency. Then we added a few more things. We did like relative frequency, midpoints, boundaries, things like that. And then we talked about histograms. There is a couple more things in this section as well. We're just going to do a flyover these two things. They're less important, but they still are important. And that are what we're going to call, I always like to ask students before I say this word, how they would pronounce it. It's fun to listen to you guys say that. It looks like Ogives, right? This is actually pronounced Ogive. So it's, Ogives. Ogive, and that's Ogive. And dot plots. So today we're going to just do a brief overview of those two. Shouldn't take too long. First thing is a little review over what we called cumulative frequency. So cumulative frequency, that's when we're going to sum all of the frequencies for that particular class and all of the classes before that and divide by the number of data points. So you can think of it as cumulative frequency is the sum of all prior plus current class, whatever one you're talking about, over n, which is the number of data points. Now, this actually gives us what we call the cumulative relative frequency. Throw that in there. Cumulative relative frequency. If we were to just sum all of them, if we just did cumulative frequency, it would just be the sum of all prior plus current. Just a slight difference between those. We actually, on the tables, we actually did the cumulative relative frequency. A lot of big words in there, but that was the sum of that one and all the prior divided by the number of data points. If we don't actually divide, which is this, what we're just talking about here, if we don't actually divide, then we're just talking about the cumulative frequency. So if we do divide by the total number of data points, that's called the cumulative relative frequency. Generally, you're just given one of the two and you'll figure it out. But general, it's just that current frequency plus all the ones prior to it is cumulative. Then if you ask for cumulative relative, sometimes it won't even say that. It'll just assume the relative part. Then you're going to divide by the number of data points. So hopefully that's clear. Now with this data, there's actually a special graph that we use to graph this, and that is what we call the ogive, or the ogive, right? So this is just a graph that displays these cumulative frequencies. It's a special graph that only displays cumulative frequencies. Sometimes a ogive is also called a cumulative frequency diagram, or it could be called a cumulative frequency polygon. I've heard that before. So ogive displays cumulative frequencies. Sometimes it's just regular cumulative frequencies. Sometimes it's cumulative relative frequencies. Regardless, it's for displaying cumulative frequencies. And this is what they look like. They kind of look like line graphs, right? It's kind of what it is. It's just we put some dots and then we connect them. And always it's going to be increasing the entire way. It's always increasing because we're talking about a cumulative, which means we're adding them up as we go before, the one before. So you can see this one, the first one is actually a relative because on the side here it has the decimals, 0.1, 0.2, all up to 1. So at the end we end at 1 because that's the cumulative relative frequency. This one isn't necessarily relative. You can see just the numbers here. So at the first one we might have had 0, and then after the second one we had maybe 10. By the third interval here, class, if you add this one plus whatever this one is, then you would get the 30. So it's adding them up as we go. It's not that the last one has 100. It's that if you add up all of the prior ones, so all the prior ones gave you up to 90, and the last one's up at 100, well, that means the last interval would actually only be 10 because it takes 10 more to get from 90 to 100. Same with this one. So like if this one was at 30, right, and the next one's up here at maybe 75, well, the class from here to here was not 75, it was whatever the increase would be from here to here. So that's actually 45 from this particular one. Just in an ogive, we're adding them up as we go. So same as in this one, we start at 0. This first one will always be the same. Looks like it's about 0.19, right? The next one here is up at, let's say, 0.42. Well, it's not to say that this price of about 200 is 0.42. It's actually 0.42 minus 0.19, so that would be, what, 0.23 would be the difference from here to here. So this particular category is 0.23, but if we're adding them together, 0.23 plus the 0.19, that gives us the 0.42. So we're just summing them up as we go. So that is an ogive. The second one you should be a little bit more familiar with. You've probably at least seen these before, and that's a dot plot. You don't necessarily need to know the definition of this one, just really know how to read it. And we'll do a couple practice problems reading this. Dot plot displays the frequency of each value by using a dot above the corresponding value on the horizontal axis, and the dots are stacked for repeated values. Here's a couple examples of what these look like. They're basically less complex histograms. I like to think of them as less complex histograms. The reason I say that is because you're displaying the same data. It's quantitative data, right? Just like histograms. All of these are quantitative, not qualitative. Quantitative means counts or numbers. So it displays quantitative values. You can see here 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. However, notice there's no intervals, right? No intervals. And we don't make like, fancy bars or anything. It's just, we're just doing dots. Sometimes you'll see X's, but it would still be called a dot plot. Basically, again, it's just sort of a less complex, sort of a dumbed down version of a histogram. We just put the dots, it's easier. And again, we don't have to calculate those intervals. In most cases, it will always just be single values. You could have an interval, but most cases it's just single values, and you just write the dots there to show the frequency of each one. So 0 has 1, 1 has 5 there. You can just count from there. All right, so hopefully you have at least decent understanding of those two. Again, you're going to have a couple quizzes over this material and then over the whole section in general. As always, reach out to me if you have further questions.